Welcome back. Unit 5, Simple Interest, Part 2, Present Value and Equivalent Payments. My favorite, equivalent payments. So let's say we're faced with the situation where we know how much money we're going to get in the future, and we want to know how much do we have to invest today to get that sum of money. That's a realistic problem too. Hey, we've got a formula for that. All we have to do is take that maturity value formula that we had, rearrange it so it solves for the present value or principal amount, and boom, hey, we're all set. Notice in that formula the exponent is a -1. That is so important. Now, if you don't like the negative exponent, you can use it and put the 1 plus RT in the denominator. However, when we start to work with equivalent payments, the -1 becomes a little bit easier to work with. You're going to have to do the 1 divided by the denominator anyway. So in the era of calculator, it's probably easier to use with the -1. I have to write all this stuff down. The -1 is a nicer representation, a cleaner representation of when you have multiple payments happening in the same deal. Okay, so when you have multiple payments happening in the same deal, we really want to use the -1. Okay. All right, hey, that's it. Hey, holy cow, that's all the new stuff. In fact, that's all the new stuff for this unit. At this point now, it's just essentially technique, working with the working with the concepts that we already know. Let's do some practice. Again, from the text, question 8. We go on. On March the 15th, 2020, Ben bought a government-guaranteed short-term investment maturing on September the 12th, 2020. How much did Ben pay for the investment if he will receive $10,000 on September the 12th, 2020? Notice he will receive future tense. How much did Ben pay? Right? That's telling us that something happened. That is Ben's payment happened before the amount of money that he receives. So when we draw out a timeline, English reading comprehension becomes kind of important to us. Okay, so in the future, he will receive the $10,000. What we don't know is how much he puts in. And you know what? We're not exactly sure how long he's got that in there for, because it goes from March 15th to September 12th. That's not, it looks like that's a job for days between dates. DVD, 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 DVD. Okay, so we have our formula for our principal amount, and that equals to the $10,000. 1 plus R. What is R? 0.0206. And now we need to use the days between dates function to find out how long between the 2 days. Okay. You got 5 seconds, 6 seconds. Go! Whoa, okay. Ooh, I held my breath the whole time. So when we run our days between dates, we're going to get about 181 days. We're going to get 181 days. Hey, so 181 divided by 365, that's how long this money is loaned for, or how long it has to be invested for to get that $10,000. So we run that through and we get a principal amount, or an amount we'd have to invest, of about $9,898 and about 88 cents, 0.8796 and a few more decimal spots. Okay, so that's not too bad, right? Not too bad at all. Equivalent payments. So equivalent payments is great because we get to both use the S formula and the P formula. Clearly, sometimes when we're renegotiating a payment plan, it means that there are some payments in arrears. right? So we could have payments that involve the P formula, and then we could be talking about future payments as well. Okay, so this is it's a great intellectual exercise. It is from a teaching point of view, it is like the segment, the section that just gives, because it takes everything, brings it all together in one question. So it's beautiful that way. The key thing is time, right? There's a time component to all this, and payments don't all occur at the same time period. They occur across different time periods. We prefer money sooner to today than further into the future. Stuff happens as we go into the future, right? There's a rental cost. So money today is worth more than money in the future. So when we're dealing with payments that occur across a variety of times or a variety of periods, we need to select the focal date or a comparison date. It is on that focal date that we will compare, or we will consider all the payments together, right? So they're all in one moment in time. Okay, so that's a very, very important. So we'll have to select the focal date. Often in the question, the focal date's given to you. When in doubt, today is always the 0 point to today is always a good focal date. But then there'll be some special cases where the selection of a focal date makes the problem solving easier. Whatever focal date you pick, it won't change the answer. It does not matter what you pick as a focal date, as long as you pick one and as long as you compare or evaluate all the payments on that single focal date. That is extremely important. Now, I like to draw out the picture because then the next two bullets aren't really material, but some people don't see it that way, and that's fine, right? We all have our different sort of approaches to this. There are different ways that work for different folks. Perfectly cool. Okay. So if you like a more principles-based approach to it, you like a rules-based person instead of sort of a graphical-based person, then if that the due date falls before the focal date, right? So the due date is before the focal date. So you're looking from the due date to the focal date. You're looking into the future at the focal date. You find the future value using the appropriate formula. If the due date falls after the focal date, so that when you're on the due date, you're looking back in time to the focal date, use the present value formula. Okay. So either way, it's all good. So when we look at comparing equivalent payments, what does the word equivalent mean? Usually it means it's got to be equal. Now, in mathematical, it'll be that the dollar amount from one option is the same as the dollar amount for another option. They're equivalent in that they're not exactly the same. Right? So we're indifferent between the two. They both have the same value. Okay, so we look at the sum of all the replacement values and compare it to the sum of all the original payments. Those should balance out. This is a great principle, because we can then look and say, okay, that is the point I'm renegotiating the new deal. I got the old deal, I'll call option 1. I got the new deal, I call option 2. And I look and I say, okay, option 2, at what point are option 2 and option 1 the same to me? And I find that point. Then maybe that gives me a little bit of negotiating space to go, maybe I'm just going to juice up that payment in the third month by $20. And makes me a little bit better off. And so you can now negotiate with that, knowing sort of where your red line is. That point where, hey, I'm not going to do this renegotiation because you're making me worse off. That's an important point to know when that happens. The other party is looking at it from the other way, right? They've done the calculations and they want to try to get a little bit better deal. And you'd want to make sure that that better deal that they're getting is certainly not at your expense. Okay, so very important to understand how this equivalent value payment structure works if you're ever renegotiating somebody's payment plan. Or if you're renegotiating a payment plan yourself. You want to make sure, you want the new payment plan, you need a little bit of deferral, but you don't want to be made too much worse off as a result. And you have to be very, very careful with all that. Okay, now, when you make a payment, that payment has a principal component in it, and it has an interest component in it. And depending on when that payment happens, the principal and interest components will change. So you could be making 3 equal payments across different time periods, but each one of the 3 will be paying off different amounts of principal and interest. Even though when you go the P plus I and add them together, they're the same number, $1,000, let's say. But $1,000 payment in 3 months, $1,000 payment in 6 months, and $1,000 payment in 9 months, each one of them will contribute to principal differently. The earlier the payment, the more principal paid off. The later the payment, the more an interest component is in that payment, right? To compensate for the rental of that particular amount of money. Okay. So as a result of all that, when you repay the loan, the principal amount, when you look at the present value of all those payments, which is just a way of removing the impact of interest on all of those payments, when you sum them up, you must get back to the principal value. Okay, and that's called the valuation principle. Okay, so if I borrow $5,000 and then I make payments in 1 month, 2 months, and 3 months, let's say. Okay, and I come up with, I have a payment structure. I got to pay so much in 1 month, so much in 2 months, so much in 3 months. When I find the present value, using a focal date of today, of the first payment, the second payment, and the third payment, when I add up those present values, I will get back to the principal amount. Okay, so that's very, very useful to us, and it allows us to do a lot of these calculations, especially when you have multiple payments. Okay. Let's do an example. All right, let's continue on with this example. You'll notice I'm writing with pen, and I would recommend that if you're actually doing calculations for real, use pencil. I use pen because sometimes the pencil with the little webcam I've got going on here, the pencil looks very faint. Sometimes I think that even the ink is not as bright as one would like it to be, but the pencil is even fainter. So I'm doing math in pen, and that's typically not wise practice, but I'm doing it for the camera. All right. So Jane is owed payments of $500 4 months ago. Oops, Jane's a little late. $800 today, $400 in 3 months from Kristen. Sorry. Jane's owed. Kristen is a little falling behind. Both have agreed instead to make a single payment 1 month from today. Okay, let's draw that out before we get too carried away. So EQ for equivalent payments. Let's draw out that timeline so we see when everything is happening. So 4 months ago. So 4 months from today. Today is the 0 point. I'll go back in time. Should have paid $500. $800 is supposed to be paid today. I'm guessing that Kristen is not going to be able to make that. And $400 in 3 months. So not quite the scale, but I think you get the idea. Okay, so this we could call that option 1, whatever. We have another option. I'll put on a different line, option 2. And option 2 is to make a single payment 1 month from today. 1 month, single payment. Don't know what that is. Okay, so I have 2 things to consider. I need to determine what that single payment would be so that my payoff, my well-being is equivalent to what it was with the first option. Money's worth 6.5%, and the agreed focal date is 1 month from today. All right, so that means that is the focal date. That becomes important to us. Okay, we're going to look at all the payments on that date. Now, X is already on that date, so I don't have to mess around with it. But I do have to look at that $500 as of that focal date, the $800 as of the focal date, and the $400 as of that focal date. All the payments have to be compared and added up and calculated on a common focal date. So it looks like we're finding some present values and some future values, right? The $500, we're going to find the future value of the 500, the future value of the 800, and the present value of the 400, right? We're seeing that the due date for the 400 happens after the focal date, so we got to find the present value. The due date for the $800, for instance, happens before the focal date, so we're looking forward to the focal date from when the $800 should have been made, payment should have been made, and so we're finding a future value. Now these have to balance out, which means the value of option 1 and value of option 2 have to be the same. The value of option 2 is X. I don't know what it is. Now, the value of option 1, a little bit more interesting. I have the $500 payment. I'm finding a future value. So the interest rate, 0.065. It looks like it's 5 months into the future. From 4 months ago to 1 month from now is 5 months. And close that bracket. Add to that the $800. 1 plus 0.065. 1 month into the future, so 1/12 of a year. And then add to that the $400, 1 plus 0.065, and that goes back 2 months. From month 3 to month 1 is 2 months, so 2/12, and then very important, to not forget that exponent. That'll come and bite us hard if we forget that. Okay. When we crunch the numbers all through, we see that X equals to 513.5417, which makes sense because it's a future value of $500, so I expect it to be more than 500, plus $804.3333, which again makes sense because it's a future value, and then plus $395.7131, which makes sense because that's a present value. I make sure that I didn't forget that minus 1. Okay. Add them all up, and I get about $1,713.59. So this is how much money would have to be paid 1 month from now so that it is equivalent to the existing relationship. Okay, so really cool. So that's 1x. We're going to do 1x, 2x's, and 3x's here, just to kind of give us a sense for all the different iterations. And then that'll conclude this particular chapter. And you'll have pretty much seen everything now. Okay. So, question 12 here. Judy received a payment of $2,950, used it to pay back 2 equal outstanding loans. So they're the same. We don't know how much it is. Okay, so just X and another X. From 45 days ago and 190 days ago. So those 2 events happened in the past. If interest is 12.5% on the loans and the agreed focal date is today, what is the size of the equal amounts borrowed? So remember, when Stephen thinking back to Unit 2, the variable, the unknown, is always that thing that you want to know that you don't already know. Okay? And in this case, what we want to know that we don't already know is the size of the equal payments. Now we do know that they're the same, so there's going to be an X and another X, and so that makes life a little easier. But that thing that we want to know that we don't already know is how much each one of those 2 outstanding loans are or is. Okay. Let's draw a timeline so I can keep track of what's going on here. So what happened? She received a payment of $2,900 and she used it to pay these 2 loans. Okay, so today she received the $2,950. Okay, So that's like our option 1. 45 days ago, there was a payment that was supposed to have been made. I'm just going to put that on a slightly different line to signify it's a different option. And 190 days ago, there was also another payment of X that was expected. Okay. So now we need to know what those equal outstanding loans are. So the focal date is today. So all the payments are going to be examined as of that focal date, which means the X is going to go into the future and the other X is going to go into the future. So the $29.50 is equivalent to or equal to a payment of X. I don't know how much it is. 1 plus, what's our big bad interest rate? 0.125. And that's 190 days into the future. So 190 out of 365. Plus another X. And again, 1 plus, same interest rate. But it's 45 days into the future. Okay. And so now I'm just running through the mathematics here. So the math sort of falls into place once we have that timeline drawn out, and we know if we're finding future values and present values, and where all the relationships manifest themselves. The math really does just kind of happen. Okay. And so I have 1.0, because I'm working inside the brackets here, so I get a value 1.0651, still times by X, I don't know what that is yet, plus 1.0154, again, times by X. So now I'm gathering up my X's just like I did in unit number 2. And so 1.0651x plus 1.0154x, that equals to 2.0805x. Now I isolate x by dividing both sides by 2.0805, and I get x that is about $1,417.93. Okay, so each one of those payments, the one 45 days ago, 190 days ago, or each one of those loans was $1,417.93. Now notice that even though the loan amounts are the same, the amount of interest accumulated in each one of those and the amount is going to be different. Okay. And last but not least, question number 16. Has all the fun in it. This one's intense. This one has everything in it, as you'll see in a sec. On March the 1st, Bear Mountain Tours borrowed $1,500. 3 equal payments are required on April the 30th, June the 20th, and August the 10th, as well as a final payment of $400 on September 30th of the same year. You know, you want to keep your life, just simple. It doesn't matter which year. Leap year issues aren't going to be a consequence here, so whether you pick 2020 or some other year, it doesn't matter. Let's draw this all out so we can kind of see what's going on in the timeline. Very important first step. So on March the 1st, they borrowed $1,500. Okay. Now they're going to make their first payment on April the 30th, and that's a payment of X. We don't know how much that is. They're going to make another payment on June the 20th. And again, another X. August the 10th, yet another payment. And another X. Ooh, 3 strikes, you're out. And on September the 30th, they make a payment of $400. Okay. So lots of stuff happening with that particular problem. And they select the focal date of September the 30th of that year. Okay, so that means the $1,500 has to be compared on September 30th, as does each one of those axes. The $400 is already in September 30th dollars, so it needs to be done there. Okay, so you can kind of see where, holy cow, lots of things happening here. Okay, very, very, very cool. So long involved problem here. So on the left hand side we have the 1500. 1 plus 0.0675 brackets. And then we need to find the days between dates from March the 1st to September 30th. So we get to work with the days between dates function in our calculator yet again. So practice that. That's extremely important. Okay, and we're going to get 213 days if you have to do a check. But I encourage you to try this on your own just to verify that I didn't make some big goof up here, and to make sure that you know how it works. Right now nobody cares that I know how it works. We're worried about you knowing how it works. So first payment, the April 30th payment, 1 plus, and again, same interest rate. It's a little messy, 153 days over 365, and then we add that to another X, 1 plus, again, same interest rate. Different number of days now, because different number of days from June the 20th to September the 3rd. It is 102 days from June the 20th to September the 30th. 365, and then plus X, 1 plus 0.0675. And then the number of days from August the 10th to September the 30th is 51. 365, and then, and real easy to forget, is that $400. Okay, that is super easy to forget. You've done all the grunt work, you've written out all these big relationships, and the $400 who's just like sitting there, you know, minding its own business, goes, hey, don't forget me, don't forget me. Okay, so we get the 1559 and 0856. I'm just rounding this to 4 decimal spots. Okay. And now equals to 1.0283x plus 1.0189x plus 1.0094x plus the 400. So now I'm starting to get into a little bit of the algebra end of this game. So I'm going to add up all those x's, you know, collect all the common x's. I'm also going to move the $400 over to the left-hand side. Remember, as I move it from the right-hand side to the left-hand side, its sign changes, so it becomes a negative. All right, let's give this a shot here. Okay, so the 1559, minus the 400, and I get 1159.0856. Again, subtracted the 400 from the 1559 and some change. Gathered up all those x's, and I get 3.0566x. And I'm going to isolate the x by dividing by 3.0566 on both sides. And that x equals to $379.21. Okay. And that's a wrap. Right? So you can kind of see that last question, that's got everything in it. Right? I guess we didn't do a present value. Maybe that's the only thing missing. But we got days between dates, lots of them. We had the timeline, lots of payments, lots of x's, lots of algebra, lots of adding, lots of multiplying, lots of fractions. Great stuff.